KMnO4 potassium permanganate. Preparation reactions are MnO2 on reaction with alkali metal hydroxide, potassium hydroxide in presence of oxygen or KNO3 gives you K2MnO4, which is dark green in color. So this potassium magnate in acidic solution gives you permanganate plus MnO2 plus 2H2O. So commercially this magnate ion is converted to permanganate ion by electrolytic oxidation in alkaline solution. This salt is not very soluble in water, 6.4 gram per 100 gram of water at 293 Kelvin. So on a reduction means this permanganate ion in acidic medium gains 5 electron, gives you Mn2 positive plus 4H2O, and the reduction potential is plus 1.52 volt. Structure is tetrahedral magnet as well as permanganate ion. So both are tetrahedral in structure. Then the oxidation state of manganese in permanganate is plus 7. So here is the calculation, that is on manganese let it be X, and then the oxidation state of oxygen is -2 into 4 atoms is equal to overall is equal to -1. So X minus 8 is equal to -1. So X will be plus 7. So manganese is here in the plus 7 oxidation state, and other side it goes to 2 plus oxidation state. So from plus 7 to plus 2 it has attained 5 electrons. So then we will calculate the charges. So here -1 on permanganate and 5 electrons, so total -6, -6, and other side is the 2 positive. Now in acidic medium, how much extra positive charges should I add to get the 2 positive on the other side? Means 8H positive minus 6 gives you 2 positive. So permanganate plus 5 electron plus 8H positive gives you Mn2 positive. So this is the balance equation. Then to balance the oxygen and hydrogen, so on the right hand side we will put 4 molecules of water. In acidic solution, then is the oxidizing properties of the KMnO4 in acidic solution. So first example is Fe2 positive is converted to Fe3 positive. Fe2 positive gives you Fe3 positive, and on oxidation it gives 1 electron. Now in the above equation, in the first equation we'll see that 5 electrons are added. So it means 5 electrons should be released, then only this 5 electrons will be attained by the permanganate. So multiply it by 5, so we get 5 Fe2 positive gives you 5 Fe3 positive plus 5 electrons. So adding this 1 and 2 equation will give permanganate plus 5 electron plus 8H positive. Right hand side Mn2 positive 4H2 plus 5 Fe3 positive plus 5 electrons, right? So in this way we'll get this balanced equation. Then is the third equation is the example of the oxalate ions gets converted to carbon dioxide. So first of all, carbon atom is balanced. So left side is a C2, so right hand side it's a twice CO2. So here carbon is balanced. On right hand side, CO2 is neutral, so carbon is in the plus 4 oxidation state, and in on the left hand side in the oxalate ion C2O4 2 negative. So 2x, let the oxidation state on the carbon be x. So 2x plus minus 8 is equal to minus 2. 2x is equal to minus 2 plus 8. So it comes around x is equal to 3. So carbon on the left hand side, it is in the plus 3 oxidation state. So from plus 3 to plus 4, so 1 electron for 1 carbon, for 2 electrons for 2 carbon. Now, as we see in the equation 1, it's a 5 electrons are released. Here it's a are added, and here in the oxalate to CO2, here 2 electrons are released. So to balance this, so we multiply this equation oxalate to CO2 by 5 and the MnO4 by 2, so that we can balance the electrons, 10 electrons, right? So to this balance these electrons, we have to multiply this equation by 5 or the KMnO4 equation by 2. And finally we get the balanced equation 5C2O4 2 negative plus twice MnO4 negative plus 16H positive. On the right hand side gives you 10CO2 plus Mn2 positive plus 8H2O. Then H2S gives you 2H positive plus sulfide. So this sulfide is converted to sulfur. So 2 electrons are lost again. So there in the first equation 5 electrons are retained. So to balance the electrons here, that equation is multiplied 2 and sulfide to sulfur is multiplied by 5. So in this way we get the balanced equation. In the C is 2 MnO4 negative plus 16H positive plus 10 electron gives you 2 Mn2 positive plus 8H2 plus 10 electrons. Then in neutral law or faintly alkaline solution, twice MnO4, 8H2, iodide to MnO2. So in acidic it's a Mn2 positive, on in alkaline it will MnO2. So from plus 7 to plus 4 it's a 3 electrons, right? So here, and iodide is to iodate ion. So in this way the 1 plus 3 negative 4 negative charges, and right hand side it's a neutral MnO2, so it's 0. So 4 OH is added. For alkaline solution we will add the OH negative. So MnO4 negative plus 3 electron plus twice H2O MnO2 to balance the oxygen and hydrogen plus 4 OH negative into 2. So here it will be in this way. So iodide to iod3 negative. So here X is in the plus 6 oxidation state. So here the 6 electrons, X is equal to comes to plus 5. So here 6 electrons are lost. On the right hand side, left hand side it's a 3, so multiply by 2 to balance the 6 electrons, and this way finally we'll get the balanced equation. Then is the potassium dichromate K2Cr2O7. Preparation is from chromite ore to on reaction with sodium carbonate with oxygen gives you sodium chromate Na2Cr2O4. Yellow solution of sodium chromate in acidic solution gives you sodium dichromate of orange solution, and then with potassium chloride it will give it K2Cr2O7. So chromates and dichromates are interconvertible in aqueous solution depending upon the pH of the solution. The oxidation state of chromium in chromate and dichromate is the same. So that is plus 6 only. So structures are the chromate is the tetrahedral and the this is ditetrahedral. Then potassium dichromate is used as a primary standard in volumetric analysis. In acidic solution, its oxidizing action can be represented as follows. So it's chromate ion plus 14H positive, 6 electron gives you twice chromate plus 7H2. So balancing gives you here it's a plus oxygen 6 to plus 3. So atom of the chromium to be balanced, for one chromium 3 electrons, for two chromium it's a 6 electrons. So charges 2 negative on the chromate, 6 electrons, 8 negative, 6 positive. In acidic medium How to get these 6 positive on the right hand side? So 14 electrons are to be added in this. Then oxidizing reaction. So just simply, so 6 electrons to be balanced by these are the following reactions. The Fe2 positive, Fe3 positive, 1 electron. So here to balance the 6 electrons added in the chromate equation, dichromate, so multiply by 6. Then Sn2 positive to 4 positive with 2 electrons, so multiply by 3 to make this 6 electron. Then iodide to iodine, it's a 2 electrons, so multiply by 3. H2S2 to sulfide, it's a sulfide to sulfur, it's a 2 electrons, so multiply by 3 to make the 6 electrons, right, to balance with the reduction of the dichromate, that is chromium, for 6 electron from for chromium 6 to chromium 3 positive.